Hello again, welcome to another lesson in Algebra 1. Today we are covering section 8.3, Understanding Zero and Negative Exponents. So on your warm-up, you had a very short one. You were just supposed to find a pattern in each and then fill in the remaining blanks. So in our first one, you can see it's going down 5, 4, 3, 2, 1, 0, negative 1, negative 2. On the left side, so it's going down by ones on the left. And on the right side, it's going down by, well, let's see. It seems like it's dividing by 2 each time, so it's cutting down by half of each amount. So 32 cut in half is 16, 16 cut in half is 8, 8 cut in half should have been 4, 4 cut in half should be 2, 2 cut in half should be 1, and then 1 cut in half would be 1/2, or we could put 0.5 here, and 1/2 cut in half would be 1/4. Okay. All right, same kind of thing for number 2, except this time it's being divided by 3. So the first one was being divided by 2 each time. This time we're dividing by 3 each time, so cutting into it 1/3 as big. So 243 divided by 3 is 81. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3, and 1/3 divided by 3 is 1/9. Okay. Now, why do we do these? Okay. These are actually our exponent rules hidden inside of them. So this is really 2 to the 5th power. This is 2 to the 4th power. 2 cubed, that's 8. 2 squared is 4. 2 to the 1st power, anything to the 1st power is just that we don't write the 1 up there for our exponent. We've been doing that for a while. But here's the new one. 2 to the 0 power is 1. And 2 to the negative 1 is actually 1/2. And 2 to the negative 2 is really 1/4. And when we flip the page over, we'll see some rules that explain why those are the thing. So notice the weird thing is a 0 exponent makes a 1 answer, and negative exponents don't make negative answers, they make fraction values. All right, so over here, this is really, same as the other side, 3 to the 5th power, 3 to the 4th power, 3 to the 3rd power, 3 squared, 3 to the 1st power, which is 3, 3 to the 0 power, which is also 1, 3 to the negative 1 power, once again makes a fraction, not a negative number, and 3 to the negative 2 power is 1/9. Let's flip it over and see what's going on with the positive exponents, which we learned about, the 0 exponent, which is new, and negative exponents, which are new. On our second page, we have our rules here, so the definition of the 0 and negative exponents. So a to the 0 power is 1, so any number to the 0 power is 1, except for one exception. A can't be 0. So if you try to type 0 to the 0 power on your calculator, you'll see an error message. You'll say, like, can't divide by 0. Okay. 5 to the 0 power, for example, is 1. And on the first page, we notice that 2 to the 0 power was 1, and 3 to the 0 power is 1. Doesn't matter what the base is as long as it's not 0. All right, so any number, a to the negative n power is the reciprocal of a to the n. So this is what this is really saying. If you have a to the negative n, you turn it into 1 over a to the positive n. So when you change the base from the top of the fraction to the bottom of the fraction, or the bottom to the top, so numerator and denominator, we just change the sign of the exponent. And this also doesn't work if the base is 0. Okay, so for instance, 2 to the negative 3rd power is the same as 1 over 2 to the 3rd power. Okay, so that 2 to the 3rd power is just 1/8. Okay, and this is the rule in reverse. So if we had a base with a negative exponent in the denominator of a fraction, we could move it to the top of the fraction, as long as the base isn't 0. And here's an example, 1 over 4 to the negative 2. When I move the 4 to the base to the top of the fraction, it becomes a positive exponent, just changes its sign, and then 4 squared is 16. Okay, simplified exponential expressions should not have exponents less than or equal to 0. So we don't want to leave our final answers with 0 or negative exponents. All right, so use the definitions of 0 and negative exponents to simplify each. So 6 to the negative 2 power This is really 1 over 6 squared. We changed the place of the base from the numerator of this fraction to the denominator, and then we change its exponent from negative to positive. So this will work out to 1 over 36. Okay. X to the 0 power is 1, except we have one exception. X isn't allowed to be 0. Okay. 2 to the thirds to the negative 2 power. I'm going to do one of my rules we learned earlier first. First, I'm going to make this 2 to the negative 2 power over 3 to the negative power. So I'm going to multiply my outside exponent to the inside exponents. Okay. And then I know I can't work out 2 to the negative 2 power. I got to take that and move it from the numerator to the denominator and give it a positive exponent. And I couldn't work out 3 to the negative 2 power because the negative exponent doesn't work for me. So I take it from the denominator, move the base to the numerator, and change its exponent to positive. And then I just work it out. 3 squared is 9, and 2 squared is 4. All right. 0 to the negative 7 power, that's 1 over 0 to the 7th power. That's 1 over 0. So this is no good. This answer does not exist. So 1 over 0 power, no good, because, or 1 over 0 to some power, because 1 divided by 0 is an error message on our calculator. We cannot divide by 0. So sometimes you have to be really careful with that 0 base. Okay, so that's what we were talking about above. Okay, so be careful with the 0 base. All right, but a 0 exponent is great. 0 exponent, the simple rule, 1, as long as the base isn't 0. So negative 8 to the 2 power, we've already done that. Notice the exponent's not negative, the exponent's positive. So this is just negative 8 times negative 8, which is 64. And then 1 over 3 to the negative 3rd power. Let's see, I take the base of 3. I got to move it to the numerator of the fraction so that its exponent can become positive. And then 3 to the 3rd power is 27. And in our last one, negative 1 to the 0 power, that anything to the 0 power is 1 except for a base of 0. But negative 1 is not a base of 0. So we just get 1. All right, so just remember, if it's a 0 exponent, it's going to be 1. Okay, or if it's a negative exponent, then we change the place of the base and the position of its fraction and change the exponent to positive and then work it out normal. Okay, on our last page, we just have some practice with all the rules from the last 2 days, last 2 sections, plus the new rules about negative and 0 exponents. All right, so here we have a negative 2 as the base, and we have one exponent of 6, and it's times by another negative 2 to the base with the exponent of negative 6. When we have the same basis, and there's multiply, remember, we just keep the base and add the exponent. So 6 plus negative 6 makes 0. And then anything to the 0 power is 1, as long as the base isn't 0. Okay. Number 10, 3 to the 3rd power with a negative 2 on the outside. Okay, so this is our power rule. So we take our outside exponent and multiply it to the inside exponent. So that will become 3 to the negative 6 power. And then we flip the base to the denominator of our fraction so that we can change our exponent from negative to positive and be able to work it out. And 3 to the 6th power, that's 3 times 3 times 3 times 3, 6 times. And this is where a calculator comes in handy. So 3 to the 6th power is 729. So 1 over 729. Now, number 11, we get our exponent is negative, so we're going to have to change the place of the base in the fraction. So we'll take it up to the numerator, change its exponent to positive, and then 9 squared is 81. In number 12, let's see, we have a division here, so we're going to use our rule of 7, and then we do the top exponent minus the bottom exponent, which will make negative 2. And then that could be 1 over 7 squared, which is 49, 1 over 49. If I was working this problem out, though, I would notice that the bottom exponent is bigger. So I would do this instead. I'd keep the base in the bottom and do 5 minus 3 for 2. And then I'd work that out to 1 over 49. But either way is fine. So the book will always say you take the top exponent minus the bottom exponent and keep the base on top. But I like to say which exponent is bigger. It makes the problems be faster. Okay. In number 13, we have 1 over 4 to the negative 3. So the base has an exponent that's negative, so we move it up to the top and make the exponent become positive. 4 to the third power is 64. 16 times 4 is 64. And in our last one, we keep the base of 5. We do our power rule, so we times the two exponents together to make positive 2. And then 5 squared is 25. Okay. Now, with all these problems, 9 through 14, you could just type them exactly the way they are in your calculator and get the right answer. But you need to practice them trying to use your exponent rules instead, because when we get to the bottom ones, you can't do that. You can't type x and y with exponents into your calculator and get it to simplify. All right, so let's take a look at our bottom ones here and use our exponent rules to simplify these out. Notice our answers can only use positive exponents, so no 0 or negative exponents when we're done. All right, so on number 15, we take the exponent outside the parentheses and we times it to the exponents inside. So 2 to the first power becomes 2 to the third power, which is 8. And x to the first power now becomes x to the third power. And y to the negative 5 power becomes y to the negative 15 power. Now, this is all good for 8, and it's all good for x cubed, but the y has a negative exponent. So we just take the base of y, we move it to the denominator of the fraction because it was in the numerator, and we change its exponent from negative 15 to positive 15. And that is all good. No negative exponents, no 0 exponents, and everything is simplified as much as possible. All right. Number 16. Okay. All right, so up top, I'm going to go ahead and move that negative 2 in. So actually, you know what? I think I'm going to move it down to the bottom of my fraction first. So that's a negative exponent. Let's just rearrange it so it's down here so I can work it out. So that's 2x squared times negative 4x squared y squared. All right, so then I'll go ahead and work out 2x squared. So y to the 5th is up top. 2x squared will become 4x squared here because the 2 is on the outside, the exponent. And then that's times negative 4x squared y squared. I'll go ahead and simplify the bottom here. So this is y to the 5th. I'll go ahead and multiply those two together on the bottom. That'll make negative 16. X to the 4th y squared. And then we say, okay, is there anything that can still be canceled? There are some y's on the top and some y's on the bottom. There's more on the top, so I'll keep my base of y up top. 5 minus 2 makes 3. And then on the bottom, negative 16x to the 4th is left behind. Notice all my exponents are positive. We have an exponent of 3 on the y, exponent of 4 on the x, and an exponent of negative 1 on the 16, even though we don't write it. And everything is simplified as much as possible. My number coefficient in front doesn't have any exponents left. Okay, so this looks long and hard, but you just do one little step of what we've done each time. Okay. All right, in number 17, I'm going to go ahead and multiply that exponent in. So 3 to the second power will become 9. Cover up all the x's and y's. That just says 3 to the second power. And then 2 times negative 2 will give me negative 4. And 2 times 3 will give me 6 for the y's exponent. Now this is all good except for the x. So I can copy the 9 and the y and leave them on the top of the fraction. I take the x base, I move it to the denominator, and I change it from a negative exponent to a positive exponent. Okay. And in our last one, we'll look at the numbers out in front first. So 4 over 8, that's 1/2. So I'm going to write a 1/2, and then maybe I'll erase the 1 later if I don't need it to hold the spot on top. All right, so there's more x's on the bottom than the top. There's 1 on the bottom, and there's negative 2 on the top. So I'm going to keep my base on the bottom and do 1 minus negative 2, which gives me 3. And there's more y's on the bottom. The exponent is bigger on the bottom, so I'm going to do 6 minus 4 for 2. And it's a good thing I put that 1 up there because that's my placeholder to make that a fraction. All right, this concludes our notes for today. You should begin the Khan Academy modules multiplied monomials by binomials. That should be review. And use exponent rules to evaluate expressions. That's going to have some negative and 0 exponents in it, so be careful on that one. This is due the period after the next class, but you really want to get started so you can seek some help if you need it during next class. I'll see you then.